Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today for exam LTAM from the last spring 2019 exam LTAM. Problem number 11 in multiple choice section. An insurer sells a single premium 22-year term policy with a face amount of $500,000 to a 38 years old. You are given the death benefit is payable at the end of the year of death, so it's a discrete policy. The premium is calculated using this assuming that mortality follows the standard ultimate life table SULT. Please remember that you can find that table at smarturl.it/SULT. And the old one from exam MLC is at smarturl.it/ILT, which stands for Illustrative Life Table, which was its name. There are no expenses in this policy. The interest rate is 5%. The single premium is $7,245. So that's what the customers pay for this. Immediately after issue, it is discovered that the mortality rate should have been 300% of the SULT mortality rates during the first 2 policy years, but reverting to the SULT mortality rates for the remaining 20 years. The premium is unchanged. Calculate the expected loss at issue on this policy. So obviously, since there is higher mortality in the first 2 years, there'll be higher expected value of death benefits for those 2 years, and the company will have a loss on the policy. Of course, that loss will be the expected value, so it will be on average. It might miraculously happen that the company will make money on the policy, but anyway, on average, there will be a loss. The mortality rates that are 300% of those in SULT in the first 2 years equal, so I put a star next to the mortality rate to indicate that it's 3 times what SULT table says. So Q star 38 is 3 times the rate for a 30-year-old in SULT table, and that rate in SULT table is 0.000463, so 3 times that is 0.001389. And Q star 39 is 3 times the rate from the SULT table, which is 0.000493, so 3 times that is 0.001479. The expected present value of the death benefits with this adjusted mortality is, well, 500,000, that's the amount, times Q38 star, the probability of dying the first year, times 1.05 to a -1, because the death benefit is paid at the end of the year. So this is the expected present value of the death benefit in the first year. For the second year, P38 star, because the person is to live through the first year to die in the second year, times the probability of dying in the second year once you live through the first year, which is Q39 star, because the mortality is still adjusted there, times 1.05 to a -2, because we're discounting from the time 2 of the payment. The payment is made at the end of the policy year. Plus, given that the person survives the first 2 years, there's a typo here, so let me try to quickly correct it. We of course have to discount this amount, so it was correct in the next line, but not here. So my apologies. So if the person survives the first 2 years, it's P38 star, survival of the first year, times P39 star, survival in the second year, and then after those 2 years, the cost of this insurance will be A40 and colon angle 20, 1 over 40, which is the cost of 20-year term at age 40, which the person will reach then. But of course that cost is calculated at age 40, so 2 years in the future. So to bring it back, you need to discount it at 5%, and that's where this 1.05 to a negative 2 comes from, which I mysteriously have here, but forgot to put there. I apologize, but now it's corrected. And now, this number, the cost of a 20-year term for a 40-year-old, it's actually not in the SULT table. We have to find it from the data in SULT table, but the standard trick is to write it as A40 minus 20E40, so conditional on survival for 40 years, times A60. So we have 20 years worth of coverage through whole life, but we take away all the years but the first 20 by subtracting the second term, and this becomes a 20-year term in actuarial present value. And now we need to just find all these numbers. So we already figured out what Q38 star is. P38 star is 1 minus that. Q39 star we figured out. P39 star is 1 minus that. A40 in SULT is 0.12106. A60 in SULT is 0.29028, and 20E40 is in SULT table as well, and it's 0.36663. And then we take all these numbers and we calculate A40 minus 20E40 times A60, so that's 0.12106 minus 0.36663 times 0.29028, and that becomes 0.01463,464 approximately. Therefore, the expected present value of the death benefits with this suggested mortality is 500,000 times, and we just plug in all the numbers that we had in this formula, all the quantities that we have there, and we just replace them with all the numbers listed here, and then we calculate that. And it's a bit of work, but we get 7,949.25. The single premium collected is 7,245, while the actual cost is 7,949.25. So the loss at issue equals the excess of the cost over the premium, which is 7,949 minus 0.25 minus 7,245, and that's 704.25. Which is answer E. Answer E, the choice for answer E is 700, so this is the closest to the values of the 5 possible answer choices. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.